Rationalizing the denominator part 2. So in this case over here, we have a fraction a over the square root of b plus the square root of c. Now right away we see that this is a little bit more complicated than before because now we have two square roots in the denominator separated by either a plus or a minus. Now um, there's a property that I will write in a different color, property where if I have a plus b times a minus b, this will give me a squared minus b squared. Now you should see how this is actually very useful for us right here because if we multiply the square root of b plus the square root of c by the square root of b minus the square root of c, like we see here in these two brackets, what it will give us is the difference of two squares. Now, of course, what we want to do is multiply the top and the bottom here by the same amount. So if I multiply the bottom by the square root of b minus the square root of c, of course I have to do the same to the top. So square root of b minus the square root of c. Now, what this gives us is a times the square root of b minus the square root of c divided by the square root of b squared minus the square root of c squared, which of course is equal to a bracket square root of b minus square root of c bracket divided by b minus c. So we're using the property here that we have in yellow known as the difference of two squares, or shortened by dots, D-O-T-S, difference of two squares. And we're using this property to get rid of the square roots that are in the denominator. So this is rationalizing the denominator when you have two square roots in the denominator. Now, you don't have to have two square roots in the denominator to use this difference of two squares property to get rid of the square root. For example, if I have a divided by b minus the square root of c, well, here I only have one square root in the denominator, but I have this other term here. Now, how do I get rid of the square root? I will use the difference of two squares anyway. So I will multiply the denominator by b plus the square root of c. Notice it's the opposite sign as what's in the denominator. Here I have a minus, so here I have to put a plus. What I do to the bottom, I have to do to the top. Otherwise, I change the value of my fraction, and I don't want to change the value of my fraction. So this gives me a times b plus square root of c. Oops, let's clean that up a bit. C divided by, and here I get the first term squared, so that's b squared, minus the second term squared, and that's just square root of c squared, which is c. And so we started off with a divided by b minus square root of c, and we ended up with a times, in brackets, b plus square root of c divided by b squared minus c, and now there's no more square roots in the denominator. So we've rationalized the denominator, even if there's just one square root in the denominator out of the two terms.